All right, guys, today let's go ahead and start talking about Module 5, which is about probability. Probability is just a mathematician's way of saying what most people call chance. It's a way of quantifying, which means to put into numbers, the likelihood of an event occurring, or the likelihood of a certain outcome from an event, maybe is a better way of saying it. And so we represent this likelihood of something happening with numbers. When most people are talking, they use what I would refer to as chance. They say something in terms of a percent. They say there's a 50% chance this coin will land on heads, or there's a 10% chance that this will happen, or a 90% chance. Well, probability is the exact same thing, except probabilities are usually represented in decimals or fractions because we want to do math with probabilities. And you should know from Module 4 that we just completed, these numbers can be converted back and forth pretty easily, right? Percents to fractions and decimals back to percents or whatever. But anytime that you had to solve a question like what is 32% of 86, you never wound up using 32, the actual percent number. You always had to convert it to a decimal first, 0.32, and then times the number, right? So why not just leave the numbers in decimals and fractions so that we can work with them more easily with math and not really so much represent them as percents? So we'll be working more in decimals and fractions, and particularly decimals, because a lot of the numbers that we work with in this module won't be nice numbers that can be represented as easily as fractions. We'll have things like a 0.27963 probability or something, and it's like we're not going to put that into a fraction. So this will come in handy quite often in this module, just like it did in the last module, so have it available. Also, you should have clicked on or downloaded or opened the e-copy of Module 5 that was attached to today's announcement, so that you have that in case I ever ask you to do something from it, or you're having a hard time reading in the book and you want to have something that you can see more easily. All right, so chance we know goes from 0% to 100%, right? If you say something has a 0% chance of happening, that means it's absolutely impossible. There's no way it can happen, right? And if you say something has a 100% chance of happening, that means it's for sure going to happen. It's it's absolute. It's an absolute chance, or it's certain to happen. Well, probability works the exact same way, but just think of these numbers converted to decimals. So 0% is 0 and 100% is 1. So probabilities are always represented as numbers between 0 and 1. If you got a number over 1, you're messing up. You shouldn't have that with probabilities. And if you have a negative number or something less than 0, you're messing up as well. Everything should be a decimal or a fraction running between 0 and 1. All right, and so there's two types of probability that we'll be looking at. The first one is called theoretical, which is what we normally think about when we think of a probability. Theoretical probability is like what we know should happen when we perform a chance experiment. Anything that we're applying a probability to, any event or outcome is a chance experiment. So when you flip a coin, it's a chance experiment. When you roll a die, that's a chance experiment. If you're taking basketball shots to see how many you can make or whatever, each shot is a chance experiment. Well, no, I guess you could make it so that each certain number of shots is a chance experiment. It depends on how you set it up. But basically anything that you're trying to calculate the probability for or experiment the probability for, we're going to refer to that as a chance experiment. And so an example of theoretical probability would be like flipping a coin. We know that theoretically you should have a 1/2 or 0.5 probability right in the middle of landing on heads or tails, which would be the same as a 50% chance. And yeah, I know that I was writing 0.5 up here on the thing, and yeah, I know that there's this tiny little minute probability where it could land on the edge and then not technically be on heads or tails, or I suppose there's an also minute possibility that an alien could scoop it up midair and fly away with it, and then it never lands on any side or anything. Okay, I get that there's other little minute things that we could talk about, but to make our lives easier, we tend to just not get bogged down in those things, and we say the more simple fact that would be there's a 0.5 probability of it landing on heads or tails. And so that's what should happen. But we know that that's not what always does happen, right? We know that if we flipped a coin 10 times, we're not necessarily going to get exactly half tails and half heads. Life doesn't work that way. We might get 7 tails and 3 heads or whatever. And so if we're looking at things that way and we're actually conducting the experiment, we're actually flipping coins, we're actually rolling dice, and then we're basing our probabilities off of that data, then that's called experimental or estimated data. I think the book likes to say estimated probability a lot, or they say estimate the probability. So I like to call it experimental, but I think the book is going to use estimated a lot. All right, and so yeah, when every time you run a chance experiment, like every time you flip that coin, or every time you like roll a die or spin a spinner, that's called a trial of the chance experiment, right? You're trying it one time, so that's a trial. And whatever the outcome is, right? Whatever happens, we call that an outcome, and we say that we observed that outcome. So these words are going to be important, right? Observations, outcomes, trials, chance experiments. Generally speaking, we usually prefer the theoretical probability, but experimental or estimated probability can be great in cases where there's no real, like, reasonable way to calculate the theoretical probability of something. Like if you were to ask me, what's the probability that I could step outside with a basketball, throw it across the street, have it hit the building across the street, bounce 2 times on its way back to me, and land in a certain bush right outside my door or something. Who knows? How do we calculate the probability of that? We really can't. So the only way we could get a probability for it would be experimentally. I would just go out there and literally try 100 times, and then we would use that data of how many times I actually was able to get the outcome I wanted, which would be off the wall, bounce 2 times, land in the bush. That would be my desired outcome, and however many times I got that outcome, we would use that to calculate our experimental probability. So, this will make more sense as we get more into it. But what we need to start with is just getting used to kind of like the terms and what the numbers mean a little bit. So let's start there in Module 1. Where did I put that paper clip? I had a paper clip that I was going to use for this spinner. What did I do? Couldn't have gone far. Oh, there it is. Alright, so they've got this spinner here, right? And they want us to choose one of these spaces. If you were to play this game and you win the game by your space being landed in more often, which would you choose? Would you choose the green, the red, or the blue space? And the way you spin the spinner is like you have something that holds it down at the center. I'm going to use this push pin. And then you just flick the thing. Oops, I hit my own hand. And so that one landed in green, so that'd be a green. What they want you to see obviously here is that because the green is taking up the most space, the green has the highest probability of being landed on, right? And in fact, theoretically, the green has a 0.5 or 1/2 probability of being landed on because it takes up 1/2 of the space, right? And the blue theoretically has a 0.25 or 1/4 probability, and so does the red. Now this is theoretically, right? That's what should happen. Now we could play this game 20 times, and for all I know, maybe it lands in red all 20 times. That's super duper unlikely to happen, but it could, right? So theoretical and what happens experimentally are 2 different things. All right, so these few questions here on the first page of, or the second page of lesson 1 are asking about what happened if you actually did play that spinner game with a partner, which we would have done in class. And so to ask you which color was the first to occur 10 times. Pretty much every group would probably wind up saying green there. Usually there's like one pair or whatever that it doesn't actually turn out to be the green, because the green is the one that should win, but sometimes blue or red wins. And so it says, do you think it makes a difference who gets to pick their color first, right? Like if you were actually playing this game and you get to pick your color and your partner gets to pick their color, does it matter who gets to pick first? I'd say yes, right? Because whoever gets to pick first is going to pick green and they're going to win. So which color would you pick to get the best chance of winning the game? Green. All right, and so now let's look at these colors, or these spinners that we got down here. It says below are 3 different spinners. If you pick green for your color, which spinner would give you the best chance to win? Okay, so we're stuck with green. So which spinner do we want to play with? Do we want to play with this one that has green and red sort of split evenly? Do we want to play with this one where green is taking up about 3/4 of the space and red is taking up a fourth? Or do we want to play with this one where green is like less than a fourth, maybe like a fifth of the circle and red is the rest? I hope that's not too challenging of a question for you. The answer would certainly be we want to play on this one, right? If we're green, this one, green has theoretically a 0.75 probability of being landed on. Notice I'm not saying 0.75%, right? This is 0.75 probability or 75% chance. Whereas this has a 0.25 probability to land on red or a 25% chance. So this one's definitely going to give us the best chance at winning, right? And so, we'll get more into like where the math comes from this, but I hope you're kind of understanding that where I'm getting the 0.75 or 75% is the fact that the green is taking up 3/4 of the circle and 3/4 is equal to 0.75 or 75%. So it's like the ratio between how much space the green takes up out of the whole circle. All right, so let's go and skip this. I want to talk about this scale here because these words come up a lot in the problem sets, and if you were going to take the state test this year, they like to use these words in the state test a lot and stuff, and you might see them on some of the websites I ask you to practice on, so I want you to just know them. Here's your probability scale. It runs from 0. I don't know if you can see that this is kind of small, but there's a 0 right here, and there's a 1 right here. And underneath 0, it says impossible. If something has a probability of 0, that means there's absolutely, literally no chance that it can happen, or it's impossible. Then there's this word unlikely, and it sits between impossible and 1/2 here. Well, anything that it has more than a 0 probability or 0% chance, right? Even if it's just a little bit more than 0, all the way up to just a little bit less than half, 0.499999, whatever, we say that event is unlikely if it's anywhere in that range between 0 and a half. Then we get to right at 1/2. And 1/2 probability, or 50% chance, or 0.5 probability, I'm going to write 0.5 here because that's how I would normally say it. That's an event that we would say is equally likely to occur or not occur. Now, I don't know if you can read this because this text is kind of small. That's a mouthful. So lots of times in class we abbreviate this as L2NO. Equally likely to occur or not occur. It just means it's got a 50-50 chance. And then if you have an event or an outcome, that has a probability of just anything just barely over 1/2, all the way up to 1, but not quite 1, we would call that event as likely. It has a better than 50% chance, so it's pretty likely to occur. Anything in that range is called likely. And then if it has a probability of 1 or a 100% chance, we use the word certain. We say it's going to happen for certain. All right, so let's look at these 5 events that they have here and place them on the probability scale, just like sort of our estimations of where they deserve to be. So event A, you will see a live dinosaur on the way home from school today. What is the probability of that event? Well, if we were actually in school, you could make the argument that, well, maybe on my way home from school today, the guy from Jurassic Park will have dropped off a T-Rex, on my block, and I'll see it on my way home. So there is some kind of probability, and I would entertain that. But you're not even at school today. You're at home watching this. And so the probability of you seeing a live dinosaur on your way home from school today is 0. So I'm going to put event A right over 0 on the probability scale. B, the probability that a solid rock dropped in water will sink. And yeah, we could talk about salt density in the water and what kind of rock is it? Is it like a porous rock? Is it lava rock? I don't know. If you ask me, solid rocks pretty much always sink in water. So for me, I'm going to put that right over 1 for it's certain. It's 100% chance it's going to sink. If you can show me a solid rock that doesn't sink in water, show me. All right. C, a round disc with one side red and the other side yellow. They're talking about a coin that has a red side and a yellow side. What's the probability it'll land on yellow when it's flipped? Okay, that should be a 50-50, right? We're talking about a coin flip, so I'm going to put C right over 0.5. D, a spinner with 4 equal parts. So they're talking about this. You got a spinner. It's got 4 equal sections labeled 1, 2, 3, 4. When you spin it, you'll land on the 4. Okay, well, that's a 1/4 probability. So that should be right here in the unlikely section, right? It's unlikely that it will land on 4. I mean, it's not super unlikely, but chances are you'll get a 1, 2, or 3 instead. E, your name will be drawn when a name is selected randomly from a bag containing the names of all the students in your class. There's approximately 30 students in each one of my classes. And so you only have a 1 out of 30 chance, or 1/30th probability of being selected. That's way over here. That's way over here near impossible. F, a red cube will be drawn when a cube is selected from a bag that has 5 blue cubes and 5 red cubes. Okay, well, there's an equal number of blue and an equal number of red. So you should have a 50-50 chance, or a 0.5 probability of drawing a red. So I'm going to put that right on top of 0.5 probability. And lastly, G, the temperature outside tomorrow will be negative 250 degrees. I guess it's not impossible. Some weird astronomical event or global event could happen that causes the world to freeze that cold, I suppose. But it's pretty close to impossible, right? So I'm going to put G way over here. All right. So next it wants us to design our own spinner. It says design a spinner so that the probability of getting green is 1. Remember, probability of 1 means it's absolutely going to happen, 100% chance. So we have to design a spinner that no matter what, you land on green. So how about I draw a spinner that is green, and I color the whole thing in as green. Now, no matter how you spin that, you're going to get green. So green is probability 1 in that case. Design a spinner so that the probability of green is 0. Okay, so I want a spinner that has absolutely no chance to get a green. It's impossible to get green. Okay, well, how about I draw a red spinner? I color the whole thing in red. I don't even put any green on it at all. Well, I'd say there's a 0% chance, or a 0 probability of getting green on that spinner. And then lastly, design a spinner with 2 outcomes in which it is equally likely to land on red or green. Okay, well, how about I draw this spinner in black. Then I'll cut it down the middle, and I'll make one side green. Yeah, I know, I'm lazy when it comes to my coloring. Give me a break. And one side red. Equally likely, or El Tuno, to get green or red. You could have been more creative with how I split this up. You didn't have to do it 50-50. You could have made a bunch of little green spaces and a bunch of little red spaces, as long as there was an equal amount of green and an equal amount of red. All right. So that should be a good enough intro to lesson 1 for you to be able to do the lesson 1 problem set. It's pretty simple. It's just mostly asking you about the probability scale, and just it's simple stuff. It'll get a little more challenging as we go. All right.